Okay, calculate the energy required to remove the electron from a hydrogen atom in its ground state. So to actually remove the electron is to pull it a distance to where it will no longer interact with the proton in the nucleus of the hydrogen atom. And we looked at the energy equation up here earlier, and the only way that the electron would not interact with the nucleus is if it were an infinite distance away from it, right? Which we know infinity is not a real number, it's just a concept. But conceptually, the only way the electron won't interact with the proton, so if here's a proton, right, and here's an electron, the only way that the electron won't interact with the proton or be drawn towards it is if this distance is infinitely far apart. So calculating, remember we want to know the energy required to pull it off. That's going to be the energy change, delta E, which is equal to E2 minus E1. E1 is the ground state, or where n equals 1 in this equation up here. And E2 is infinitely far away from it, right? So the energy, let's calculate the energy at an infinite distance away. So remember the energy in this equation would be that n is essentially infinity, right? N is the distance out, where n is an integer, where it's 1 or 2 or 3, right? Kind of energy positions away. When I say energy positions, I mean like in that quantized region where it can be out from it, okay? So if n equals infinity, let's look at what happens to this thing. So if I plug infinity in for n, dividing anything by infinity is 0. If you struggle seeing that concept, let's do 1 divided by 2, right? We get 0.5, okay? 1 divided by something slightly bigger, divided by 3, we get 0.33. So our answer is smaller, right? It was 0.5, now it's 0.33. 1 divided by 4 is 0.25. 1 divided by 5 is 0.2. So we get smaller and smaller numbers as these numbers get larger and larger, right? 1 divided by 100, I'm putting 1,000, divided by 100 is 0.01, right? 1 divided by 1,000 would be 0.001. 1 divided by infinity would be 0 by that logic, right? I know you'll learn more about this stuff in calculus, but essentially E2 then, if this is infinity, this whole term goes to 0 in this problem. So E2 is 0 minus E1, and E1 is simply where n equals 1, and we calculated that in an earlier video, right? So E1 was just this right here, negative 2.178 times 10 to the minus 18. So 0 minus 2.178 times 10 to the minus 18. Okay, and this was negative. So minus a negative gives you plus a plus, and that's where we're getting this answer. So the energy required to pull the electron an infinite distance away, right? To pull it off, essentially is what it's saying, to remove it, is that much energy. Okay, it is just, if you put in the energy at the ground state, you can then remove it. Okay, that's all that infinity stuff was talking about. So the delta E here is 2.178 times 10 to the minus 18. Okay, I will see you in the next video.